Hello and welcome. Bhaskar Napte from Pharma Growth Hub. We all know that the stability testing is a vital part of product development. It is, however, quite resource consuming and requirement of, let us say, 6 month data for ANDAs is often considered to be a critical part of the development. Therefore, it is vital and important that the stability protocols are designed both very properly to ensure all the regulatory requirements are met and the approvals will not get suffered. But the challenge over here is, the number of samples needs to be tested. And hence, now there is a provision given into the ICH guideline Q1D in which the sample analysis time can be minimized efficiently. As a part of this presentation, we are going to understand how the matrixing designing can be of great help. Now there is a two different concept when it comes to reducing testing. One is bracketing and another one is matrixing. So I have already discussed about the bracketing part into the another video, and if you want to learn about that, please watch the video on bracketing in stability study. Now this is the video where I am going to talk about how the matrixing design can be used to reduce the sample load while stability testing. A very brief about the stability testing and where this reference has been provided into the ICH guideline, and here are these two important guidelines. The first one is Q1D, which talks about the bracketing and matrixing designs for stability testing of new drug substances and product. And the second ICH guideline, which talks about again the bracketing and matrixing concept, is the Q2AR2, that is the stability testing of new drug substances and the product. So you will find the reference of matrixing and bracketing in both of these guidelines. What is meant by stability study? Just a brief information about the stability study, and it is defined as a continued conformance of drug substance or drug product to its specification throughout its retest or shelf life. That is the stability. Now there is something called as the full study design. The samples for every combination, all design factors are tested at all time points. Means if you have a different strength, different packaging, container closure systems, you are going to define the stability testing across all these permutations and the combinations. But there is something very smart way of doing the stability testing, and that is the reduced testing now, or the reduced design. So how this can be used? So sample for every combination, all design factors are not tested at all time points. And we are going to talk about how this testing can be reduced with the help of matrixing. And this concept is well discussed in the ICH guideline Q1D. The important part is any reduced design should have the ability to adequately predict the retest period or the shelf life. And that is the meaningful justification you must have in case if you are using either bracketing or the matrixing design. Now, what is meant by the matrixing? So, the matrixing is the design of a stability schedule such that a selected subset of the total number of possible samples for all factor combinations would be tested at a specified time point. As a part of your stability plan, you have a plan up to 36 months, and there are three different strengths: 10 milligram, 20 milligram, and 40 milligram. And if you calculate the all sample load, right, you will say, okay, now I have to test almost, let us say, 72 number of samples. 72 number of samples across the three strength till 36 month. And then you are going to decide on to some part of the sample will not be tested. You will only test the sample for the selective subsets. And we'll talk about those subsets with the help of example, like a half design or a one-third design. So what is meant by half design? Half design means if there are 48 samples to be tested, you will not test 24 samples. You will only test 24 samples. Half design. One third means if there are 48 samples to be tested, right? You will not test 48 samples, but you will test only one sample out of the third sample. That means out of the third sample, the two samples will be tested and one sample will be omitted. The one third means what? Out of three samples, the one sample will be omitted. So if there are 48 samples to be tested, how many samples you can omit? The 16 samples can be omitted, right? Out of the 48 samples, the one third of 48 becomes 16 and the 16 sample can be omitted. You can only need to test 32 number of samples. That is the matrixing. But let us understand, what are the underlying assumptions you must consider. The design assumes that the stability of each subset of samples tested represent the stability of all samples at a given time point. So your subset that you are going to test must be representative of the entire stability samples. The matrixing should not be performed across the test attributes. So you cannot, use the matrixing for the number of tests. You cannot omit the number of tests by doing the matrixing. It is only possible for reducing the number of samples, but not the number of tests. So what are the various design factors you must consider when it comes to matrixing? The strength. I mean, if you have multiple strength dosage forms, you can certainly use matrixing for designing the stability protocol. So, matrixing designs can be applied to strength with identical or closely related formulations. So, what is meant by identical? What is meant by closely related formulations? We are essentially talking about the dose proportionate formulations, not much difference from one another. And here are the examples. The first one is capsules of different strength made with different fill plug sizes from the same powder blend. Again, the dose proportionate formulation, just the size of the plug get changed with the change in the strength or the label claim. Similarly, for tablet of different strength manufactured by compressing varying amount of the same granulation or the blend powder. Again, the dose proportionate formulation is expected for the tablet too. In case of oral solutions of different strengths with formulation that differ only in minor excipients like colorants or the flavoring agents. So these are the exceptions provided for the oral solutions. Otherwise, the oral solution also looks like the same dosage forms. I mean the same composition across the different strength. It can be just different container, it can be just different fill size, or it can be a composition which is having the similar kind of API to excipient ratio. The second situation where you can use the matrixing is the container size and the fill of the container. So matrixing design can be applied to batches made by using the same process and same equipment and same container sizes and or fills. Let us now understand the what are the different considerations that you must have in mind before starting the matrixing design. A matrixing design should be balanced as far as possible so that each combination of factors is tested to the same extent over the extended duration of the study and through the last time point prior to submission. All the combinations, all the subset should get the equal opportunities, and that is the purpose of having the meaningful matrix design in the place, and we'll talk about this concept with the suitable examples. All selected factor combinations should be tested at initial, 12th month and the final time point. Now that is something very important. Even though we talk about the one half designing or the one third designing, but when it comes to initial, 12th month and last time points, you are not allowed to exclude any of the sample. All the samples has to be tested for 12th month and for last time point, including the initial time point, that is T0. Now, for matrixing at an accelerated or intermediate storage condition, care should be taken to ensure testing occurs at a minimum of 3 time points, including initial and final. Minimum 3 points are required for the accelerated and intermediate storage conditions. Now, here is the example of the design factor with the strength. Now, this is the valsartan capsules formulation with the 40 milligram, 80 milligram, and 160 milligram as the dosage strength. And these are the dose proportionate formulation. Just look at the screen and you'll understand there is a same ratio of API to excipient across all these three different strengths. Let us talk about the first concept, the first design, that is a one-half reduction. Now, what one-half does? It eliminates one in every 2 time points from the full study design. So if you have two samples, the one sample will be eliminated and there is a necessity to test only one sample. Let us now understand the situation where you have two different strengths, S1 and S2, and we know that there are three batches required as a part of your exhibit batch stability or as a part of your primary submission batches for your ANDAs, DMFs or NDAs. And you have planned to test this product at initial 3, 6, 9, 12, 18, 24 and 36 month. So altogether, if you calculate the number of testing point, how many are there? There will be 48 test points across 6 batches, 3 from S1 strength, 3 from S2 strength, and across 8 different intervals. So there will be 48 testing points. 48. And as we discussed, the few minutes ago, it is mandatory to have the testing at initial, at 12th, and at the last time point. So if you look at now the your stability plan for with the matrixing designing, you understand what are the requirement for initial 12th month and this 36th month time point. Now what is the leftover? The leftover is only 3, 6, 9, 18 and 24 month. Right? The 3, 6, 9, 18 and 24 month. Now these are the time points which were only left behind. And then include the one half of the required testing points. And then as I said that it should be a meaningful. And this is the one of the example given inside the ICH guideline Q1D. So altogether, once you have this entire plan now, the expected reduction was how much? The 24. Because 48s are the total number of time points. So one half means 48 divided by 2 becomes 24. So I was expecting there will be only 24 number of samples to be tested if I use one half reduction. However, the testing at the initial, final and 12th month time point is required and hence added into the testing plan. Initial, the 12th month and the 36th month. Let us understand the third important point. Potentially, matrixing will be applicable for 30 points excluding T0, 12 month and the last month. 30 points. 30 points. Therefore, ultimate reduction is less than one half. Means I was expecting to have the 24th time points excluded, but I end up getting only exclusion for the 15 time points. Now measure the counts the empty boxes. For batch 1 in S1 there are 2 exclusions. 1, 2, then 3, 4, 5, 6 and 7. Right? 7 from S1 strength and then there will be 1, 2, 3, 1, 2 and 1, 2, 3. So 8 from the S2 strength. So 7 plus 8 becomes 15. So I got I got omission of the 15 time points out of expectation of 24 time points. So it can be understood that during the matrixing design, the number of reduction will not be exactly half, but it will be less than the half. I was expecting 24 exclusions, but I end up getting only 15 exclusions. And you know the reason behind that. Because the initial, the 12th month, and the last time point samples are required as a part of your testing plan. Let us now take the little complex scenario where there are three different strengths and three different container sizes. Let us assume that you have a tell me certain tablet with the label claim of tell me certain 20 mg, tell me certain 40 mg, and tell me certain 80 mg. You got three different strengths. And let us assume that you are going to pack these three different strengths into three different container sizes. One is 30 cc container, other is 60 cc container, and third one is the 90 cc container. Right? So here on the screen, you will find that the three strengths are denoted by S1, S2, and S3. So these are the three different strengths. The container size is denoted by A, B, and the C. And the same containers will also be used for the second strength and the third strength also. So you will find ABC common across all three different strengths. Now, as a part of this 3A table, right? The 3A table, what is mentioned over here? That is mentioned that the matrixing on time points. That means only time points are considered, and container size is not considered while making the design. And how the design is made? Look at here for the batch number 1, 2, 3, across the batch number 1, 2, 3, and these are the configuration. These are the time points I need to consider when I talk about the S1 strength, when I talk about the container size A, and when I talk about the batch 1, that is a T1. I repeat, if I talk about the strength S1, if I talk about again the container size A, and if I talk about the batch 1, I should have the T1 testing plan, the plan given by the T1. Now this is called as the key. This is called as the key. What is meant by T1, by the way? Look at here now. There is a definition of the key given over here. The T1 means I need to have the testing across this many time points. At initial, then at 6th month, then at 9th month, then at 12th month, then at 18th month, then 24th, and then 36th month. Essentially, when I talk about the any T1 testing plan, I have to test the batches at these particular time points. Let us talk about the batch number 2 for the S1 strength for the container size A. And if you look here, it becomes now T2. Batch 2 becomes T2. So what is the T2 means? The T2 means I need to test the batch for 0, for 3, for look at 6 is omitted, right? Then the 9th month, then 12th month, then 18th is omitted, then 24th and the 36th month. So batch 2 will get tested for this many time points. Let us now understand. In case of S1 strength, in case of container size A, what should be the testing points, the time points for batch number 3? And that gives me a configuration of T3. And what is the T3 means? Look at here, the T3 means 0 month sample, 3rd month sample, there is 6th month is not required, it is omitted, then again 9th month is required, then 12th month is required, then again 18th month is excluded, then 24th month is required, and 36th month is required. Essentially, this points, the T1, T2 is actually going to provide me the number of time points for a strength, for a container, and for different batches. Let me explain you with the help of the full-fledged table now how this looks like when I substitute the values of T1, values of T2, and values of T3 for all the strength for different container size. And this is the exact stability plan that you will come across where there is a matrixing done on only time points. So here is the key for strength S1, right? I'm talking about the first strength, that is S1 strength, and I'm talking about the container A, container size A, and look at here the batch 1. The key is T1, and the T1 indicates what? Now this is the testing points across the T1 key, and hence I must test batch number 1 for container size A from strength number S1 at these many time points. Similarly, for batch number 2, right, the key is T2, and hence the batch 2 will be tested for these many time points. For batch number 3, the key is T3, and hence the batch 3 will be tested for these many time points. So I got the entire testing plan for the container size A. Similarly, if I go back and check now for the container B, what is the testing plan? T2, T3, and the T1. This is the container B. Batch 1 will be tested across the T2 key. The batch 2 will be tested across T3 key. And batch number 3 will be tested according to key name T1. T2, T3, and the T1 for batch number 1, batch number 2, and batch number 3. Let us go back again. T2, T3, and T1. And here is the definition of T3, T2, right? Time points. Here is the definition of T3, and here is the definition of T1. Similarly, if I go back to the container C, what I found? T3, T1, and the T2. Now this is the plan, the T3, T1, and the T2. So let me check the T3, T1, and the T2, isn't it? So what is the definition of T3? Here is the definition of T3. Here is the definition of T1, and here is the definition of T2. So by having this key information, the key, I can able to design my all protocol for the S1 strength for different container size for 3 different batches. Similarly, I can also calculate the testing plan for the another strength, that is S2, and for the S3 also. So there is a little confusion about the how this information to be read, especially when you look at the ICH guideline Q1D, the detailed explanation is not provided over there. So there is information about this particular matrix plan design and only this number of keys, but how to connect this information and bring into a proper design is the important point, and this is the information that you must look for. S1 strength, the S2 strength, and the S3 strength. We got the design for all the different strength where only the matrixing for time points are considered and not for the different fill or the container size. Let us now understand. We have a 3 different strength and 3 different container sizes, and we are going to talk about how the matrixing can be built by considering this both the factors, the time points as well as the container size. And here is the design for S1 strength having 3 different container size A, B, C. Now this is the testing plan, the T1, T2 for batch number 1, then again for batch number 2 T3, T1, and for batch number 3 T3, T2. I'm just taken this information from the ICH guideline Q1D. Now let us understand the keys. So keys are going to remain the same. I hope you remember that how we connected the keys with the designing part. So T1 stands for the testing at initial 6 month, 9th month, 12th month, 18th, 24th, and 36th month. T2 key stands for testing at initial 3rd month, 9th month, 12th month, 24th, and 36th month. Similarly, the T3 key stands for testing at initial 3rd month, 9th month, 12th month, 24th month, and 36th month. So now we have to substitute these values of the key at the respective places. Let us now understand how we can build the protocol for the S1 strength with the container size A and having the batch number 1, 2, and 3. So for S1 strength for container closure A, there is no testing proposed for batch number 2. right? There is no testing proposed for batch number 2. So there will be testing for batch number 1 according to key T1, and for batch number 3 it is according to key T3. Look at here now. This is S1 strength, the container A, B, C, right? And for container A, now this is the batch number 1, which is according to T1. As I said that there is no mention about the testing requirement for batch 2, the batch 2 is empty. And then for batch 3 it is T3. And this is the meaning of the T3 key, and this is the meaning of T1 key. I just given the information over here. So I got now how the container A will be tested for the S1 strength. Similarly, if I have to find out the requirement of container B, now here is the strength S1, here is the container B, and I need to test batch number 1 according to T2 key and batch number 2 according to T3 key. There is no mention about the testing of batch number 3 for container B. It's empty. Look at here, the cursor. So batch number 1 belongs to T2, batch number 2 belongs to T3. Remember this. Batch number 1 belongs to T2, batch number 2 belongs to T3. So substitute the definition of T2, T3 over here, and as I said that there is no mention of batch number 3 for container B. Let us understand the requirement of the C. So for the S1 strength, for the container size C, there is no necessity to test batch number 1. And for batch number 2, there is a need to have the key as T1. And for batch number 3, you need to adopt the key as per T2. So batch number 2 T1 and batch number 3 T2. Let us go back and check for the container C. So container C, again there is it T1 and T2? Yeah, it is T1 and T2, right? So T1 and T2 for batch number 2 and 3, there is no mention about the batch number 1, so it is empty over here. And I have just given the definition of T1 and the T2 over here. So we now understand the complete testing for the strength number S1 across the different container sizes like A, B, and C. In the similar way, you can also do it for the S2 and S3 also. I hope you understand how this key can be utilized to exactly understanding the design by using the matrixing on time points and factors. And the factor is what over here? The factor is the container size. The three different containers like A, B, and C. So what is the important limitations of the matrixing? Now, due to the reduced amount of data collected, the matrixing design on factors other than time points generally has less precision in shelf life estimation and yields a shorter shelf life than the corresponding full design. That is the biggest limitations of the matrixing. And the second one is when a matrixing on design factors is applied, if one strength or container size and or fill is no longer intended for marketing, stability testing of that strength or container size and or fill has to be continued to support the other strength or container sizes and or the fill in the design. That means what, you started with the 5 different strengths, but for some reason your marketing team has dropped out 2 of the strength, and this 2 strength information is no use to you. But as the protocol is designed with the 5 different strengths at the beginning, you need to continue this 2 dropped strength also throughout your stability life, at least for the exhibit batches or your primary batches, which are going to be a submission data. I hope you now have the better clarity in matrixing or in using the matrix design while stability study. Thank you so much.